Students, welcome back. So today what we're going to be talking about is Lab 10. Lab 10 is probably one of my favorites. It's linear regressions. It's my favorite just because this is the most applicable to real life. We use this in forecasting. We also use this in econometrics, and all those are applicable. So if this stuff sounds interesting to you, this is what happens at the next level. So Lab 10, we're going to look at linear regression. This is basically a statistical method we use to determine the relationship between dependent and independent variables. So we'll talk about all of those. So the introduction, we're going to go through regression, the definition, a linear regression, scatter graph, slope and intercept, the OLS, or the least square method, and then also an example. So introduction, it's basically, we analyze the specific relationships between two or more variables. Now this is done to gain information about one through knowing values of the others. So in our example, as well as our lab, we're going to look at education and income. So in your head, think about the relationship between education and income. What do you think it's going to be? So for the most part, it's always going to be positive. If you have more education, we know that you're going to have a higher wage. Now, there's other things that play a role as well. It's not just education. It's also experience, your age, your gender, your location, and so forth, the field you're working in, all these other things that are taken into account. Now, a regression is a statistical measure that attempts to determine the strength of the relationship between one dependent variable, which is going to be y, and a series of other changing variables known as the independent variables. So you've already seen a regression in your everyday life, especially if you've taken a math class. It's just y equals mx plus b. That's the easiest way to look at regressions. Now we're just going to add a couple more variables to it, and you're going to see how it impacts our y variable. So y is always our outcome or our dependent, what we want to find out. Our independents are always our x. So our slope, it's always going to be x, and how does it affect our outcome? So in this case, y is going to be our income, x is going to be our education. How does education affect income? Now we use this to forecast values of dependent variables from the values of independent variables. So we can use this for forecasting to predict, okay, if this individual has 15 years of education, how's their income going to look based on other characteristics? So in statistics, regression analysis includes many techniques for modeling and analyzing several variables. When the focus is on the relationship between dependent and one or more independent, we use regression analysis. So dependent and independent variables, there's a lot of different characteristics and rules that you need to know, which will be mentioned in lecture. So the independent variables are regarded as inputs to a system and may take on different values freely. Now dependent variables, so our outcome, are those values that change as a consequences of the change in our independent variables. So how does income affect, or how does income change when we're a different gender, or when we have higher levels of education, or if we live in a densely populated area? How is it impacted? So independent variable is also called a predictor or explanatory variable. So if you see explanatory or predictor, that's always going to be your x. So independent equal those, just get used to that notation. Dependent variable is also known as response variable, and it's denoted as y. So the simplest mathematical relationship between variables x and y is a linear relationship, so y equals mx plus b. In a cause and effect relationship, the independent variable is a cause, and the dependent variable is the effect. Now, least squares linear regression, so we call this also OLS, is a method for predicting the value of a dependent variable y based on the value of an independent variable of x. So what we've been doing, we're going to predict what our income is going to be based off of our education. So our first order linear model, so here we have our y. Y is your dependent variable, beta 0 or beta naught. This is your y-intercept. So when you think of y equals mx plus b, this is your m. Or I'm sorry, this is your b. This is your intercept. Now, beta 1, that's your first coefficient. This is the slope of the line. So x is going to be education in this case. Y is going to be our income. So we have a y-intercept, x is education, beta 1, this is the slope of the line, or beta 1 coefficient. And this e at the very end is our error variable. So basically this takes into account all the variation between your data, and it spits it out into this last part. So for the purpose of our lab, we're going to focus on y, beta naught, beta 1, and x. We're not going to worry about the error term. That's much more complex. Okay, so the slope of the line is a change in y for a 1 unit increase in x. So this is an important part of the lab, and I'll talk about this when I do the lab portion. You're basically interpreting the slope. So what happens as education increases? So every 1 year increase in education, how does your income react, basically? So that's just slope interpretation. Now, when our slope is 0, that means it's going to be our beta 0. Our beta 0 is our y-intercept. That's what our income is going to be if we have 0 years of education. So again, this is just basic stuff. Here we have an example of our linear regression. So first we're going to need to have a scatter plot. With that, you can see the trend. So with this data, you should be able to tell that it has a positive trend. It's increasing through these data points. Now the random error term, we're not going to really talk about this. Definitions of a scatter plot. Scatter plot or a scatter graph is a type of mathematical diagram to display values for two variables for a set of data. So again, you're just plotting these points and it's going to show you some type of relationship. A scatter plot is a graph made by plotting ordered pairs in a coordinate plane to show the correlation between two sets of data. So with linear regressions, you also get a correlation coefficient. Now with this, it'll show you how closely related your data is. So if it's closer to a positive 1, it's a positive and it's strong. If it's closer to -1, it is it's negatively correlated and it's strong. If it's closer to 0, there's very little correlation. The points are going to be very scattered. So scatter plot describes positive trend as one set of value increases, the other set increases as well. A negative trend as one value increases, the other decreases. And the position on vertical axis, this kind of plot is also called a scatter graph. So we'll talk about that in the lab. So here we have our scatter graph or scatter plot. We see an increase. Our response is our y, explanatory is our x. So these are independent. This is your dependent. So as we see an increase here, you see an increase in the outcome. So here, this is the least squares estimation of beta 0 and beta 1. Beta 0 is a mean response when x equals 0. So this is your y-intercept. If you have 0 years of education, you're going to have this amount of income. Now beta 1 is a change in mean response when x increases by 1 unit. So if I ask you to calculate beta 1, I want you to calculate the beta 1 coefficient, which means you're interpreting your slope, basically. Beta 0 and beta 1 are unknown parameters. Beta 0 plus beta 1x is your mean response when an explanatory variable takes on the value of x. So if we have 10 years of education, this x value right here would be 10 multiplied by your coefficient plus your beta 0. Now the goal is you choose values estimates that minimize the sum of squared errors, or SSE, of observed values to the straight line. So here, this is our function. This is our function for sum of squared errors, SSE. It's a summation of y per observation minus y hat. Y hat, anytime you see a hat, this is your predicted value. This is what should be based on our data set. And now this also equal y hat is just beta 0 plus beta 1 per x per observation squared. So we'll go over all of these during the lab. The least square estimate of the slope coefficient of beta 1, so you will need to know this formula. Beta 1 is a summation of x minus x prime, y minus y prime divided by the summation of x minus x prime squared. And the way you find beta 0, it's y prime minus beta 1 multiplied by x prime. Alright, so the regression line generates what is called the least squares regression line. This line takes the form of a plus bx, so you can also replace that with y equals mx plus b. Now, your y is y hat. This is a predicted value. So based on everything in our data set, what should our number equal? So based on our data set, on our research, what is your income if you have 12 years of education? Okay, so such a formula can be used to generate values for a given value of x. For example, suppose a equals 10 and b equals 7. And if x is 10, then the formula produces a predicted value for y is 45. So basically, we're just plugging in 10, 7 up into this function up here. So 10, 7, and 10. So it's going to be 10 because that's your a, your b, which is your beta coefficient, which is, oh, I'm missing something. Okay, so they're assuming that the beta coefficient is 5. So if x is 10, the predicted value for y is going to be 45. We'll go over a more specific example during the Excel tutorial. And it turns out the two variables x and y, there is an equation that produces the best fit linking x to y. So again, predicted value. We don't need to know that. So here we have example. We have temperature and we have sales. Y is our dependent, x is our independent. So we want to see how temperature affects sales. If there's a higher temperature, are we increasing sales or decreasing sales? So here we have our scatter graph, and we notice there's a positive relationship. So it's basically saying as temperature increases, sales are going to increase for ice cream. Okay, so that's going to be it for the introduction to linear regression. If you guys have more questions, by all means, message me, drop a comment, set up a Zoom session with me. I'm more than happy to talk more about this. You guys are you will cover this in your lecture part of this class. So if you need more or a better understanding, please, by all means, stop by. I'm more than happy to help. But other than that, I will show you guys a tutorial in the next video. Thank you.